sorry?
It's read by everyone.
By everybody. Every single method can see it, right? By the way, for those who were not here in last class, on the exam, one of the, just everybody had that error, and I didn't take any points because maybe I feel that maybe I didn't explain it correctly. Finals, okay? I mean globals, do not go inside the main. If most of the people say that the final goes inside the main, they don't. Because if you put something inside the main, that would be a local to the main method. Okay? So the finals always have to be outside of all of the methods, and the best place to put them is all the way up on top. Okay, some people put them all over the place, which it works, but it's kind of confusing. If you put all of your globals all the way up on top, you know that all the globals are up there. Okay, you don't have to be chasing them when you're doing that. And the locals go where?
Inside.
Inside, and they can be seen by the method of the inside. Okay, nobody else can see them. So the local to their own methods. All right, so that's the one, right? So we created the mini post guide here that we had all along. And then we created another method here, which these things are really nice to do. And you probably use them from time to time as you go programming. If this method I created here, I call it PL. You can call it whatever you want. So every time that I need to do system period out print line to create a line feed, and instead of rewriting all of these, I just go ahead and put PL, and it does it for me. So tricks like that, they're useful. Okay, so I recommend that you guys start doing things like that to make your life a lot easier. Okay, so let's go down to the main guide. So, can someone tell me what this section is doing here? For 20 points, who wants it? No. Okay, so basically over here we are creating an integer, right, called results, and we're setting it to 0. So I didn't mention this before, but this is the perfect time. Java, when you don't initialize a variable to 0, it automatically initializes it to 0. That's one of the very few languages that do that. Most languages do not do that. Okay? So my advice is to get into the habit of always, when you create a variable, always initialize it. Okay? In C, for instance, you have the RAM, right? If you go ahead and integers results like that, you will put in memory. And whatever is in that area of memory, that will be the value of results. So if in there you have, I don't know, a C, or, you know, a name or something, so results is going to be equal to that, which could be a big problem. Okay?
You have to put it in there even though it's
No, what I'm saying is anytime that you declare a variable, like, you know, what is it? I'm trying to think of the name to it, I forgot. Like the integers, they're what? The primitives. So anytime you initialize a primitive, anytime you initialize a string, anytime you initialize an array, anytime you initialize something, you create something, set it to some value so that you already know that it has the value that you're actually looking for. Okay? A lot of times over here we created things like a string, we did stuff like the string name, right? So the correct way of doing it, not for Java specifically, but for the other languages, immediately, if you don't want it to have anything, go ahead and initialize it to nothing. But it's already initialized. It already has a value of nothing. You don't want the compiler to go ahead and give you garbage. That's what it's called, garbage. Java doesn't need it, but the other languages so what we did here was we initialized that guy. Then I'm saying the results equals this guy. So what is this guy doing? This is a regular method. I want to make sure you guys understand the different methods. If you don't do that, then you can't do the constructors.
It's adding the numbers and putting it into results.
Exactly. So it's calling a method called add numbers. It's calling a method. It's passing two integers. And whatever this guy does with the two integers, is putting that over here on results. Okay? You need to 100% make sure that you understand those things, okay? Then over here, I'm just printing the results. And again, as we did on the other page, you can do this like this, or you can do it in one line by saying, I want to print just like you did here. And then inside here, you immediately call the method passing the parameters. This is more efficient. You don't need to create results, and it does it in one shot. Just like what we did on the other program. Okay, so what is this guy doing? Okay. But he's doing exactly the same thing, right? It's calling a method called subtract numbers. It's passing two integers again. And whatever this guy does, puts it over here. Okay? And this one does exactly the same thing, right? And based on the names of these methods, that's the other thing that I wanted to point out. Always make sure that the methods, the name of the method is exactly what the method does. So this one was doing adding. This one was subtracting, this one is multiplying. Okay? So by looking at the name of the method, we already know what they do. This one over here is different. This is dividing. So how about, why is this different than this guy? I'm passing two integers here, right? Why am I I'm asking for a result to be a float, not an integer? That's easy.
You can have some decimal because
Exactly,
you
right.
divide.
If you pass in a 5 divided by 3, and if you expect back an integer, you're going to get over here what? 1, right?
1.
A 1. So you're missing all of the different, you're missing all of these guys here. Okay? So one of the problems with computers is that when it comes to math, computers make a lot of mistakes. Okay? And we don't really think in those terms, but it's true. And what happens is that, remember we have integers, then we have floats, we have doubles, right? We have another one called long that we never saw here. Okay? And the difference between these two guys is what? The amount of decimals, remember? So this one has 38 decimals, this one has 387 decimals, and this one's at 100 grams. Okay? So the rule of thumb here is that the smaller the precision, the bigger the error. The larger the precision, the smaller the error. So when you guys go to work for NASA, when they come back alive, and they tell you to do the projection to go from here to Venus, make sure you use the longest number that you can find, because the amount of error in the calculation is going to be a lot less. If you use a float as opposed to a long, and instead of going there, you probably go over here, because the error will be tremendous. Okay, so we got this subtractive. Now we know about the float. And if we have, this is just review, okay? If you're dividing two integers, a 5 by a 4, right? And the answer that you want on this guy has to be a float. How will you write that? What is it you need to do to that guy? Let's assume results equals that.
Good.
Put the in print percent.
Right.
You have to decimal percent to approximate.
No. What you need to do here is you need to, it's called promote, okay? It's also called cast. In all of the languages, they call it the same, cast to promote. You need to promote one of these two guys to a float, okay? And the way you do it is, on front of it, you just put float, parentheses, okay? You can promote it to longs, you can promote it to doubles, and if this was a double, you can now promote it to an integer if you want to.
So if you're doing it the shorter way over there, you can just put a float in front of the.
In front of either one of these two guys. Okay, and what happens here is that if you go ahead and you put this like that and you put float, this is going to give you an error. Okay, it has to be exactly in front of either one, this one or that one. Okay, not on the total amount. Okay, so we know about method